Well, now let's use our skills, law of sines, law of cosines, maybe a little third angle sum theorem here and there, to solve a triangle. And when we're talking about solving a triangle, we're talking about finding all the side measures and all the angle measures based upon what we've been given. So let's look. We got a triangle here, ABC, and I got side A and side B and side C. And I'm given a little bit of information here. One, I'm told that side B is 10.2 and side C is 9.3. And I've got an angle measure here of 26. So as I look at this, I've got side, angle, side. Now when I recognize that I've got side, angle, side, well, I can start by using the law of cosines. And first I want to find the measure of angle A here. And so the law of cosines would allow me to set this up this way. I've got A squared equals B squared, 10.2 squared, plus C squared, 9.3 squared, negative 2 times B, 10.2, times C, 9.3, times the cosine of 26. All right, so I still got A squared here. And let's go through here. Let's see, 10 squared. I better turn my calculator on. 10.2 squared plus, and I'm going to do this part in one step, 9.3 squared. Well, that equals 190.53. 190.53. And then I've got negative 2 times 10.2 times 9.3 times the cosine of 26. So let's see, negative 2 times 10.2 times 9.3 times the cosine of 26. And I think I've already made sure I'm in degree mode, so I should be okay. And that is negative 170.519, so minus 170.519. All right, so let's see then. A squared is going to equal the difference between those two, 190.53 minus 170.519, and that is 20. So A squared is equal to 20.011. Well, let's take the square root of both sides here so we can get A by itself. And now I've got this A is equal to the square root of 20.011. Let's see, so I'll go second square root, second answer. And we're going to round that to the nearest tenth, and shazam, that is equal to 4.5. So now I've found this measure, 4.5. All right. Now, I've used the law of cosines to start with, but now I'm in a position I really could use the law of sines. And I always want to use, when I'm going to the law of sines, after cosines. Let's go to the longest side first. Well, I can now say that, I'm going to move this right here, that the sine of 26, using the law of sines, over 4.5 is equal to the sine of B over 10.2. And let's see, let's multiply by both sides. So I got 10.2 times the sine of 26 over 4.5, and that's going to equal the sine of B. But in order to do that, I want to use the inverse because I'm trying to find an angle measure. So I'm going to use the inverse sine to find this angle measure of B. All right, so let's see. I got 10.2 times the sine of 26. About to make a mistake there. There you go. Let's see. All right. Now I'm going to use, that's 4.47139. I'm going to go ahead and move over to the inverse sign, so control. So let's say I'm going to get the inverse sign up here, and we're going to divide it by 4.5, enter, 83.5. We're going to round that to the nearest degree, and so the measure of angle B then is 84. So we have found that this is 84. Well, what have I got left? The only thing I've got left is this angle C. And I could go through the law of sines and all that, so on and so forth, but why not just use the third angle sum theorem, which is 180 minus 26 minus 84, and that should give me the measure of angle C. So let's see, 180 minus 26 minus 84. And the measure of angle C then is going to be approximately 70. And Shazam, we have solved that triangle. And I want to do one more. Let's see what kind of situation we have here. All right, so I've still got the same triangle. I'm told that the measure of angle, side A is 6.4. And the measure of angle B is 81 degrees, 81. And the measure of angle C is 46. So I need to find the measure of angle A, and then I need to find side B and side C. Well, you know what I think I'm going to do? I think I'm going to go ahead and find the measure of A. And I'm just going to use the law of sines. I got angle, side, angle. And when I recognize I've got angle, side, angle, or angle, angle, side, I can jump straight to the law of sines. Let's see. Well, I could go about that a couple of different ways, I suppose. Well, let's just use the law of sines. No, I need to find angle A. So let's see, angle A. Well, I can use the third angle sum theorem. 180 minus 46 minus 81. 180 minus 46 minus 81. And the measure of angle A is going to equal 53. All right, so now I've got this measure here. So let's find side B. That should be the longest side. It's opposite the biggest angle. So I'm going to just use the law of sines. I'm going to go to the sine of 53 over 6.4 is equal to the sine of 81 over B. And well, let's see, let's do a little cross multiplication. So I got to B, well, I'll do it in longhand. Usually I cut out a step here. B times the sine of 53 equals 6.4 times the sine of 81. And then B is going to equal 6.4 times the sine of 81 over the sine of 53. And let's perform that calculation and get an approximate length for B. So we got 6.4 times the sine of 81 divided by the sine of 53. And that's 7.915. We're going to round that to the nearest tenth, and so that is 7.9. So we can say here that B is approximately equal to 7.9. Well, we can take this information now and continue to use the law of sines to find the measure of side C. So again, I'm going to set up the sine of 53 over 6.4 equals the sine of 46. 46, erase that, sine of 46 over C. And again, we're going to do a little cross multiplication, and when I do, I'm going to have C is equal to, I'm going to shortcut this one step because I'm running out of room, 6.4 times the sine of 46 divided by the sine of 53. And with that, I should be able to get the measure of C, at least an approximate measure of C. Approximately. All right, well, let's go. 6.4 times the sine of 46 divided by the sine of 53, and that's 5.76. We're going to round that to the nearest tenth, 5.8, and shazam. We've used the law of sines in this case because we had angle, side, angle to solve a triangle, and man, we are skilled.